16. Hi, excuse me, Mr. Pan. We cannot hear you for some reason. Hi everyone. I'm Alex. So for some technical reason, Mrs. Pan was unable to share his screen. So just let me share my screen for right now. Yes. So can everybody see my screen right now? Okay. So for the ACSL the context two, we are focused on the prefix and infix. Hi, Mr. Pan.
Please go ahead.
Okay, so give me 1 second. I think I in the wrong slide. Yeah, I found it here. So prefix and postfix notation. So this is only on top of for the elementary school device for Compare 2. So as we are watching a short video after, and then on the video you will decide what's prefix and what's infix and then what's postfix and how we cover to prefix and then how we cover to infix example. Okay, so let me jump to the video. Okay, anyone hear the words on the video?
Yes.
Can't hear it.
So you guys cannot hear what's happening right now?
I can see your screen.
Can you hear what the video?
Yes, I can see the video. Oh, I
No.
cannot hear the video. No, I
Okay.
cannot hear.
Okay, just how to fix that? I don't know how to fix that. You know how? Yeah.
Binary number system.
Can you hear the video right now? Like before?
Yeah, it seems like. Would you please play the video? Let me hear.
Yeah.
Good morning. Welcome to Computer Science tutorial
Yes.
channel. In this tutorial, we have to learn what is the number system in computers. Let's start. When we type some letter or words or anything in computer, the computer translate the data into numbers because computer is a electronic machine. To represent data into the form of numbers, computer architecture support the following 4 types of number system. Number 1, decimal number system. Second, binary number system. Third, octal number system. Fourth, hexadecimal number system. What is the decimal number system? Decimal number system is a number system which use 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to represent any kind of numbers into the computer. Decimal number system use 10 digit, therefore its base is 10. We can also call base to radix. For example, here is a 1, 2, 3 is a decimal number. Decimal numbers are represented by the base 10. What is the binary number system? A number system which use only 2 digits to represent any kind of number is called binary number system. Binary number system use only 0 and 1 because it uses 2 digits, therefore its base is 2.
This is not the topic.
For example, this is the binary number.
Hi, excuse me, Mr. Pan. What's the issue right now?
I mean, this is a numbering system, right? So that's a
Yeah.
first round topic. We are discussing the second round topic.
Okay, got it. So I just play the video. You touch the link.
Oh no, don't play that video. I'm sorry. That's my bad. Yeah,
Okay,
just go through the slide. It should be okay.
Okay, got it. Okay, so let's look at the slide. So let's talk about infix notation. So when you try to write a plus b, we write a plus b as we know. A multiplied by b is a multiplied by b. That's very basic, right? So this is called infix notation. Infix is most natural notation we through in elementary school. Here, A, B are opening plus or multiply by the open return. And then we are talking about prefix notation. Instead to say A plus B, we say add AB, or we wrote plus AB. A multiplied B will be multiply A and B will be row multiplied AB. This is a prefix notation. And the postfix notation is AB. We put the opener after the open as AB plus. To multiply AB, we wrote AB multiply. This is parser notation. And for example, infix notation requires two parentheses. For example, 2 plus 3 multiplied 5. So when we do plus first, we need to use a bracket to make 2 plus 5. And then we multiply 5, which will get 25, as we all know. But when you multiply, you use 3 multiplied 5. So we got 15 plus 2, which is 17. So parenthesis is parenthesis, and the explanation is mean how much time it for. Multiplication and divide is multiply, and it's these two things. And subtract, as we all know, is plus and minus. Okay, let me look. Okay, so what about the plus one, like 2 plus y, 2 plus multiply? Same question. We wrote 2 plus 2 multiply 3 and 5, which gives us 15. 15 as 2 is 17. And then here multiply plus, it means we plus 2 and 3 plus first, and then we multiply. No parentheses was needed. Font was opening before the calculator. Calculate was right to left. Press right opening first. If two value is mostly like multiply and divide, we always go to right to left. Like what's plus 6? Like okay, let's use also example 2 plus 3 multiply 5. So in here, we use plus first because it's 2 plus 5, as you can see here. 2 plus 5, it is, you see the signal everyone here? It means multiply 3 by 5, which gives us 15. And then we add all together. And here is it use plus like this after a function number. So it's 3 plus 3, which gives us 5. And then 5 multiplied 5 is 5. So no parent was needed and found the opener before the calculate. This one is also left to right, and left is we do the left first. On previous one, we do the right first. Do anyone confused on this even two one? Okay, so prefix is right to left. It's like the opposite. Okay, so it's like a lot of people didn't understand. I know this is a little challenge for you guys. So you can understand as we look at the signal right. Do anyone right first? Like let me go back to the prefix. Okay, first. So let me grab a pen. So for this example, we are look at right. So we start look at here. Let's look what signal is here. It's 3 multiply 5. So it means we multiply 3 multiply 5, which we all know is 15. And then and then we add 2, which got 17. But how is different look at in the bottom? It have lots of difference. So we look at right, it didn't have no sense. So we are looking at the left, which is 3 plus 5. And then we multiply 5. So which gives us 25. Do you have a question on prefix notation?
Question.
Yeah, say it.
And so why do you put the plus sign on the left and then the 2 on the left also? I thought you were supposed to put the plus sign only on the left and then the 2 on the right side.
Okay, so this is different. You are talking about, I believe, let me find it. So I believe you are talking about what we call infix. So with infix is like basically like what you're talking about. But the prefix, you just need to from right to left. Do you get that right now, or you still confused on it?
Yeah, I got it.
And then you can understand prefix and suffix is like opposite of each other. One is right to left, and the other is left to right. So we are looking left first and then right. Okay. So on the prefix, that one, we always look. Okay, let me erase the citation I wrote. So for second example, we are looking right to left, right? So we are looking here. Here didn't have any notation on it, correct, right? And then we see 2 plus 3, which gives us 5. So we basically look at what's the two number between them have a plus or negative side. If you have plus, we do plus first, and then we multiply 5. Do anyone still confused on that part? You student so I don't get it. Okay, got it. So everybody understand what's going on right now, right?
Yes, thank you. We can move on.
Okay, got it. So under computation, they will ask you a question: how to make infix to prefix. How about anyone? How about that? Everybody try to not look at the answer to do this type of question, and then we'll go over together. How's that sounds like, Mr. Pan?
Yes.
Okay, how about that? I guess you guys 5 minutes to think this question.
Wait, what did you say?
Yeah, you may go through that example. So just show us how it was converted from the infix to prefix. We cannot hear you. Are you still speaking?
Oh, sorry. Can you hear me right now?
Yes.
Okay, great. Sorry, I just accidentally muted myself. So they just don't do the example for right now. I just go over them, and then we have other example to go over them, right? It's on. Okay, so for this question, you need to understand x is equal to x b subtract cd. Yeah, how we do it? So first, we put the all value we need on there, and then okay, well you need three pair. Okay, so why you need three parameters? Okay, so because what you do in a question is A multiplied by B is together, and just for clear to let you guys understand which one and which one should go first. So you need three parentheses, which is bracket. So in this question, it's A multiplied by B, and then subtract C multiplied by D, and then power to the E. Correct. Nobody's still confused on this part, right? Okay, then. And then we just break it up to each other. And then we know it's multiplied. AB need to multiply together. So we just should multiply side before AB to the plus. X, it means, oops, sorry. X, or, sorry. X, it means it moves to the front of the, where we are looking on left, right to left. And so we need to put the multiply before AB because we are doing A multiplied by B first. Oops, I don't know. And then we have divide. So we are putting divide after CD. Then okay. And then we are subtracting 2. So after we divide it and then we multiply it. Then
打掉了，别再说了。你上次已经没有成那个。
hi sister, can you mute yourself? iPhone.
上次那个。
Because can someone mute him? Okay, thank you very much, Mr. So so someone asked a really good question. Just why x minus? Because x minus is A multiplied by B, subtract C multiplied by B. So when after we did multiply and divide, and then we are minus these two together. You still confused or you understand? Okay, then let's click on, and then as this signal, as we know, power. So it means after all, we are power to the E. This one, remember, is left to right. Okay. Which part you don't understand? Really don't understand? I'm just wondering.
Yeah, Alex, I think you can emphasize that the key here is that they are really come from the parentheses first, because the parentheses always have the highest priority. So when you see the A multiplied by B, which is inside the parentheses, that's how it comes first. So do the C divided by D. So that's also inside the parentheses. That's why you see the AB will be moved the multiply to the left first. And then it's CD, it's not a minus, because the minus, it's really not really deal with another parenthesis. Instead, the C divided by D was really inside the parentheses. So they have the higher priority to calculate that first. So it's based on the calculations sequence.
Okay, so someone just asked a question. Why do you move the minus in the front? Actually, that's a really good question. Because after we multiply A and B, we have bracket. Don't forget we have bracket after A and B subtract C and D, C over D. Minus means this is mean AB subtract CD, and then we power to E. So we need to multiply, we need a minus before, after multiply it. Do you still clear on that, or do you get it? Okay, you still get it. So remember, on prefix, we are looking at right to left. So which is on the left side have a higher priority. So C, we are doing C multiplied D first, and then we're doing A multiplied B, and then A multiplied B subtract C over D, and then power to the E. So we need to put a negative subtract on the before the multiply side. Do anyone have confused? Still have confused on prefix and postfix?
Yeah, I think the most important part here is that when you are really use the prefix, that's naturally how you are told in the elementary school. So how you make the calculation, right? So just thinking about how you naturally make the calculation, and when you convert to prefix or postfix, you just make the same sequence. So you are really A times B first, then you have the C divided by D next. Then you will use these two different results to get the result by minus in between of them. So that's really the natural way how you calculate with the infix sequential. So just thinking like that. The rest of that is just practice. It should not be that hard. I mean, both infix to prefix and infix to postfix is the same thing, just reverse direction. Yeah, thank you, Alex. You can move on to the next example to postfix so they can see how it works.
Okay, got it. Okay, next one is infix to postfix. So we are looking in left to right. So we still have still example. So in here is A multiply B. So we put in multiply sign in the front of B because we are looking left to right. And then we put a minus in the slash, and the minus to remember AB is CD is minus AB. And then we have a power. It means into is power of the AB of CD. Does anyone have a question on that? It's most likely the same, but we are looking the opposite way of the prefix. Do anyone have a question on that?
Yeah, if not, we can move on to the next slide.
Got it. Okay, on this question, just try to guess by just try this question first, and then we go over together. How that sounds like, Mr. Pan?
Yeah. Thank you.
Okay. 5 minutes. Do that enough?
I think we do not have so many time. 2 minutes should be fine.
Okay, got it. Okay, got it.
Yeah, anybody if have question, please raise the hand or just put in the chat so we can discuss. This is pretty much the very similar question like what they will ask to challenge your understanding of the infix to prefix and infix to postfix. And this is with a number instead of the letter, right? So you can make the calculation. Of course, the calculation is only in the infix, but you need to convert that into the prefix. Just see how you can convert it. The whole example is like this, but you can make your own calculation. Yeah, and you can give the result and post in the chat. See what's result you get. Okay, I think we have time out. So Alex, would you like to go through that? Okay.
Yes. Okay. So prefix, it means right to left. So let's look at this problem. Oh my God, yeah. Yes, it's left to right. No. Just let me, yes, it's right to left. Perfect. Yeah, it's right to left. So first, we need to divide the bracket first. So which gives us 3 multiplied by 5 plus 8 plus 3, so 7. So we are looking at the bracket first. We are dividing the bracket first, which gives us 7 plus 5. We put the minus sign before 7. And then we rotate the bracket to by power in the front. Then we are 3 multiplied by 4. We are canceling 8/2, which is if and then we put the multiply side of 3 4 in the front of the 3 multiplied by 4. And then that's it. That's all basically. You just put in something, put every bracket in the front instead of power put in the very front of the equation. Do anyone still have a question on this one? Because
I think it should be okay. We can move on to the next slide.
yeah, got it. Okay, this one is prefix to infix. So you just basically you just redo what I do. Just if you see some standard before number, just put it on there first, and then just use your time to think about what is happening. So for this one, streams of 5, you just put 3, but also like between 3 and 4, and then put the divide between A and 2, and then you put it with front top side in the back, and then you just redo how do you get prefix. And then postfix to infix. Okay, this is a very nice one. Hope that I guess we got still 2 minutes to try this question.
Yeah, just thinking like this. The postfix is pretty much means the number, it's really before the operator. So 3, 4 is before the multiply, and A2 is before the divide by, so on and so forth. Prefix is really on the reverse side. So that means the operator is before the number. So you have 3, 4 is after the multiply, and A2 is after the divide by. Just thinking like that. The rest of that is just how you practice and make sure you understand the parentheses is always have the highest priority to make the calculation first. If without parentheses, that means you will have to complete the calculation inside the same parentheses. So it's very natural, like what you are make the calculation based on your knowledge from the elementary school. That's what we call the infix. So it's really all about how to translate your knowledge of math into the computer, how they deal with the number. Just thinking like that. Okay, Alex, you can explain it if you like.
Okay, so this question, remember, philosophy, it means to right to left. So we just redo, we just put the multiply between the 3 and 4, and then we put divide side between A and 4, and then we put plus side, which is back on which they are starting at. Then, oops. sorry. Then we are putting everything backward to the calculator, and then we just power them together. It's very simple. Don't overcomplicate it. Don't overthink about this type of question.
Exactly.
Okay,
so that's about topic number 1. And thank you, Alex. And I will ask Eddie to share her screen to discuss about the topic number 2.
Okay, let me stop sharing my screen.
Okay.
Hi, Eddie. You can share your screen now.
Hello?
Yeah, we can see it.
Can you hear me?
I can hear you.
Okay. So the bit string flickering topic is only for junior division. So this is a term to denote operations that can be done to binary strings. So it can be done to like multiple strings or just one string. And I'm going to go over the 3 types. The first type is bitwise operations. So this one has 4 main operations. It's not, and, or, and XOR. So not is an operator that performs logical negation on each bit. So the zeros become ones and the ones become zeros. So you have ones, you have these, but then you change this 1 to a 0 and then this 0 to a 1, and you do that for all of them. So that's what not is. And is used for, you can only use and if 2 of the values are both ones, then the final one's 1. So this first one is 1, and the next one's the one, so the first one's 1, and this 0 is, this first one for this number is 0. So it, the value of it is 0 because they're both not ones, only one of them's 1. So for example, the last one is 1 and this last one's 1, so then the value of it's 1 because they're both 1. Or is just basically only one of them one of the numbers have to be 1, then they're both, then the value of this 1. So for example, the first number for this one's 1, so the value of both of them is 1. And the second number is 0, and the second number for the second one is also 0. So then 0 because none of them are 1. XOR is if the 2 values are different, then it's 1, but if they're the same, it's 0. So for example, the first one, it's 1 and the second number is 0. So the output's 1 because they're different values. And this only works if the string is the same length. And if it's not the same length, you have to add zeros to the left of the number until it is the same length. So for example, we have x is 0, y is 0. And if we do not for x, it's 1 because 0, well, not is just changing 0 to 1 and 1 to 0. And x and y 0 because they're both zeros, and has to be both values have to be 1 already. So let's say x is 1 and y is 0, then x and y is still 0 because they're not both 1. But
x or y is 1 because one of them's already 1, and or means that you can just have one or 2, or both can be 1. And x XOR y, it's 1 because they're different values. If they were the same values, for example, if x was 1 and y was 1, then it'd be 0 because they're the same values. The next operator we're going to do is the shift operator. The shift operator is just shifting the place value of the number to the left or to the right. So for example, the first one, and also if you have like a 0 or if you have 1, okay, so for the first one, it's shift 1 to the left. So we just move each of these numbers 1 to the left. So since this 1 is already at the very left, we have to get rid of it, and we add a 0 to the very end. So we get rid of it and add a 0 to the very end. So after we move them all, it's like this because we just move this one. We just get rid of this one and add a 0 to the end since we got rid of the first one. And shift to the right. So this one's saying shift to the right 2. So we just move all the numbers to the right 2 place values, and we just have to remove these ones because they're already at the end and add zeros to the beginning. So that's what we have now. Okay, the next one is circulate. Circulating is similar to shifting, except when it shifts out of the number. When it shifts out, we don't replace it with a 0. We just move it to the other side, to the end of the number. So for example, we have circulate 3 to the right. So we just move all of these numbers 3 place values to the right. Since these 3 numbers are already on the very right, we have to move it to the end. So then it's just like this. And this one's saying circulate 3 to the left. So it's the same thing, except we have to get rid of these 3 and move them to the end because they're already on the very left. So we just move these 3 and just put them on this side. I'm sorry, this one's wrong. Okay. So now we'll just look at the example for this quickly. So for example, we have the numbers 0, 1, 1, 0, 1. If we shift it to the left 2, we just get 0, 1 and put 2 zeros at the end since these are already on the very left. So it's 1, 0, 1, 0, 0. And we can do for 1, 0, if we want to circulate it 3 to the left, since 1, 0. So first we move the 1 to the end, but then we have to move the 0 to the end again because there's no other numbers. So and then we move 1 to the end again. So our final answer is 0, 1. Does anybody have any questions?
Yeah, if you have question, you can ask or you can put in the chat. It's okay. or you don't really find question now, you find question later, you can post in the Google Classroom. That's fine. Thank you.
Okay, so now we're gonna look at some examples that will be similar to the test. So right here it says we have the first one. So wait. We also have to do order of precedence. This is kind of like PEMDAS, which in math it's the order of operators which you do first before the other ones. So the order of precedence is not, shift, and circulate, and, XOR, and OR. And for shift and circulate, it's whatever one that's on the very left. Okay, so now we're going to do some examples that will look similar to the ones on the test. So this one we have to do the ones 10110 and 11010 first, because it's in the first parentheses. So remember, and is if both values are 1, then the final value is 1, but if only one value is 1, then it's 0. So this first one's 1 and the second one's 1, so that means that it's going to be 1. But since the second one's 0 and the second digit's 0 and this one's 1, then it's 0 because only one of them's 1. And we keep doing this until we get 1, 0, 0, 1, 0. Next, we have to shift these numbers to the right 1 because that's what's next in the parentheses. So remember, shifting is just moving the values one place to the right or to the left. In this case, it's to the right, and adding a 0 at the end, or how many numbers you got rid of. So here we just move this 0 to the very end, since we move every digit one place value to the right, and then we just put a 0 at the end. Next, we have, yeah. Okay. Next, we have circulate 2 to the left. So remember, circulating is just moving. It's similar to shifting. You just move it, in this case, every digit 2 places to the left, and then replacing the ones that circulated out and putting it at the very end. So in this case, we put these 2 digits to the very end since we shifted them out, since there's no more places to move them. So it's 0, 0, 1, 0, 1. So now we're going to do this one here. So remember that the order of precedence for this one's not and that and then or, because like I said earlier on the previous slide, it's from highest to lowest, so not, shift, and circulate, and XOR and OR. So that applies to this. So we have to do not first because it's the highest one. So not 0, 1, 1, 0, 1. Remember, not is just changing all the zeros to ones and all the ones to 0. So since this is a 0, we change it to 1. This is a 1, we change it to 0. This is a 1, we change it to 0. This one's a 0, so we change it to 1. And this one's a 1, so we change it to 0. So that's what we have after performing the not operation. Okay, so now we have to do and because that's the next highest one. So when we do and, we don't use the new value for this number. We still have to use the old value of 0, 1, 1, 0, 1. So and is, remember that if both values are 1, then it's 1, but if only one value is 1, then it's 0, and if none of them are, and if both values are 0, then it's 0. So we have 0, 1, 1, 0, 1, and 1, 0, 1, 1, 0. Okay, so we have, since the first one's 0 and this one's 1, then the output's 0 since they're not both 1. And then this one's 1, this one's 0, so it's 0 again because they're both not, only one of them's 1. But now this time they're both 1s, so the output would be 1. This time this one's 0, this one's 1, so the output would be 0 since they're both, since only one of them's 1. And then the final one, this one's 1, this is 0, so the output's 0. Okay, so now that we did the not and so now we have to do or. So when we do the or, it's with the new values after performing the not and the and. So we have down here 1 0 0 1 0 and or 0 0 1 0 0. So remember or, it's like and, but only one of the digits can have to be 1. They don't have to both be 1 to have the output be 1. So here, the first one's 1 for this digit and this one's 0. The output would be 1 because one of them is already 1 and it doesn't have to be both values of 1. But now the next one's 0 and this one's 0, then the output would be 0 because none of them are 1. So this one's 0, this one's 1. Since there's already one of them's already 1, then the output would be 1. This one's 1, this one's 0. So the output would still be 1 since one of the digits is 1 and it doesn't have to be both. And then the last one's 0 and 0, so the output would be 0. Okay, so our final question we're going to do is this one here. So when you look at this one, there's parentheses, so we have to do what's inside the parentheses first before doing the and function. So let's start with this one. So it's 11001 XOR 10110. So remember XOR is if, let's say we have we have the digits 1 0 1 and 1 1 0. Okay, so the output for 1 and 1, since they're both the same digit, it would be 0. And for the second digit, 0 and 1, since they're different digits, it would be 1. And for the third one, 1 and 0, they're different digits, so it'd be 1 again. Okay, so now let's do this one. So the first digit's 1, and this one's 1. Since they're the same digit, then the output is 0. For the second digit, it's 1 and 0. They're different digits, so the output would be 1. Now we have 0 and 1. So they're different digits, so the output would be 1. We have 0 and another 1. So they're 0 and 1 are different digits, so the output would be 1. And we have 1 and 0. So the output would be 1 again because they're different digits. Okay, so now we can do this one here. Sorry, I accidentally clicked the wrong button.
That's okay.
So I'm just gonna write what we had before.
Yeah, you can circle the bottom. They already have that, so that's
Okay.
fine. Yeah.
So now we have 10110 or 01100. So this one, or is only one of them has to be 1 for both of them to be 1. So this one's 1, this one's 0. So one of them's already 1, so the answer is 1. This one's 0, this one's 1, so then it's 1 again. This one's 1, this one's 1, so it's 1 because they're both 1, but so or could work if they're both 1 or if only one of them's 1. So this one's 1, this one's 0, so it's 1 again. And this time they're both zeros, and since none of them are 1, then it's 0. Okay, so now we have both. We can do the and. We can do and. So and is both of them have to be 1 for the output to be 1. Okay, so the first one here, 1. This first one here is 1. The second, and this one's 0, so it's 0 because they both have to be 1 to be 1. So we keep doing this. This one's 1, this one's 1. So the output would be 1. And these two are 1, and these two are 1. So we know that the next two ones are 1. And the final one is 0 and 1. Since if you remember, and they both have to be 1 to be 1, it's 0. Does anybody have any questions?
I think it's good.
Okay, thank you.
Thank you. Okay. Let me share my screen now. And thank you, Alex. Thank you, Eddie. Okay. So I will present the last and final topic.
I say something quickly as what you say.
Okay.
Okay, just guys, remember during contact, don't share your code or post code on any social media. This includes your classroom because that kind of cheating. Remember that, guys.
Yeah, that's right. Okay. So about topic number 3 is that for junior group, we always have this topic, and it's really talking about how to do the programming. But just remember that it's not really bound to specific language. So it's not about Python, Java, C++, C#, any language. They are not really talking about that. Instead, they are really talking about something called the pseudocode. What pseudocode really means is that they are just trying to give you the logic. They don't really try to run this as the real code. So this is called pseudocode. Pseudocode can be really right into each specific code programming language. So that's not really the ACSL try to test you. They are really trying to test you. It's a pseudocode. Okay, so when we're talking about the operators, they have multiple different operators. In case you already learned a little bit about the Python or even Java, you're probably familiar with this. But if you're not, we can go through that. But most of these are really posted in the articles. We will post the articles, so they will give you more details. For time being, I just quickly go over that. So you have the NOT, you have the exponent, you have the real division, or you have the multiply, or you have the modulus. You have all of this: larger than, smaller than, larger than and equal, smaller than and equal, something like this. Not equal. Okay, this is and. So this is all. Okay. Don't worry too much about if you don't really get it. We will post the articles so you have all of these details. And also about functions. So functions is really try to abstract the logic which can be used repeatedly. For example, the ABA means absolute value. So in case you have the negative value, you use the ABX, you can turn that into the positive value, something like that. Square is square root, integer, generate that as an integer, something like this. And so do we have the variables. They just say, okay, you can start with a letter, only letters and digits, but different language have its own rules. So this is really just something called the pseudocode. And you have the sequential statement. What's a sequential statement means? Just like when you go back to home from the school, you have the sequential way how to get into your own room, right? So you take off the school bus, you walk to the front door, and you open the door, and then you go probably upstairs, and then go to your room, open your the door of your room, and then sit on your desk. So that's the whole sequence. The sequential statement is pretty much the same like that. So it's really describe how you are doing the computing. Okay, so more important is about the decision statement. So the decision statement really means how you make the final decision. So for example, they have the if, else, and if. I give you some example from your life experience. So when you go to the, take off the school bus and go to the front door, just in case you have a keypad, you can enter the key and open the door. So you can enter the key. If that key match to the key what your parents set up, the door will open. So that means this part will work. So if the key you entered is matched to the key your parents set up for the front entry door, the statement will be open the door. But if you accidentally enter something wrong, what will happen? The door will not open. They may beep and give you some sort of like warning, right? So that's really, even in your own life experience, you can see that a lot of times you have the decision statement. So do the loop. So here we have the while loop first. So that means when this condition is true, you will continue doing this. So that means while something is true, you will continue doing. Let me give you some typical life experience. So when you count if you have sibling in your home, so you count, if you count a number and play the game, say, okay, if the number is smaller than 5, you will have to write down the number. So you will write 1, 2, 3, 4, 5. But when the number is larger than 5, you stop right that. So that's really like this. While number is smaller than 5, every time you increase that number 1. So that's from the 1 to 2 to 3 to 4, 5, 6, right? So when it's 6, it's already out. So 1, 2, 3, 4, 5. So that's something you will go through the while loop. So do the for loop. The for loop is different from the while loop. That means they will have something which you can increment. And you know how many times you will base on this condition to start and this condition to end. And inside there will be the statement. Okay, so the for loop, very typical example is same thing like how you count a number, right? So you have the number 1, 2, 3, 4, 5. And every time you can write your number, say, okay, I will write 1, I will write 2, I will write 3, and I will write 4, write 5. So this will repeat 5 times, but this repeat is really defined from here. Instead, they are not really defined by this condition. Okay, I just give you a very high level example, but that's not really bound to any of this programming language. And next, we have something called array. The array, if you're thinking like this, okay, let me write something annotation. Okay. Okay, array is something like this. In your classroom, right? So for example, this is your classroom. You have each one have a desk. I just make up. So each one sit on their own desk. Okay, so you can consider this as an array. And if you only have one row here, that can be considered as one-dimensional array. So that means, okay, you only have one row and each one have, for example, this one belongs to Ken. And this one this desk belongs to Sarah. This one belongs to Alex. Okay, so this is one-dimensional array. But in your classroom, most likely you have multiple rows, right? So you have this side direction, and you also have this direction. So this called the two-dimensional array. So on and so forth. You have three-dimensional, even four-dimensional, up to over there. So it's really something you can think about. The array, it's something you can put as a list, you can repeat. So you have the desk, you can repeat the same desk. So that's something you can put in the array. Okay. Of course, I'm not really talking about something more advanced, like you can put different type into the same array. I'm not talking about that. Okay. Let me see if I need to clean up that. Okay. Okay, now we go back to another very important concept. Let me see if I can clean up that. I forgot how to clean up that. But anyway, the string really refers to the one or more characters, and they have the index position start from 0 as the first character, and then the empty one have the length of 0. Okay. So I will give you some example. You do not have to worry about that. This is probably a little bit hard to understand. When I give you example, you will understand it. For example, this is the string. They have the ACSL space. Remember, there's a space over there. They have the work WDTPD. Okay, so this has a length of 10, and the D is the location at 9. Okay. And then you have this, means from the start. So this is empty, right? So that means the first one is empty. You don't really start from anything. Instead, you start from 0 first. So this empty means pretty much it's just 0. So you are start from 0. So this is 0. Okay, let me write this down. Okay, so if you're thinking about that, this is position 0. This is position 1, 2, 3. And the space here is position 4. And then W is 5, D is 6, T 7, P is 8, another D is 9. Okay, so that's index. And then you have from 0, so this space really means 0. So this 0. From 0 to 3. So 3, it really means first 3 characters. So this is not position 3. So the first 3 is that from A, C, A. So that's first 3. And then you have from the position 4. So that means A, C, S, L. This one, remove, take the last 4 straight. Okay. So that means from this one, that's the end. That's the last one. what's the last one is a D, right? So that's 9. So from the D backward, you take all of these 4. So you have the DTPD. So this is the open end. The open end means you go to the last one. And then you have 2 to 6. So that means you start at location 2. So that's, just remember the first one is always 0. So ACS. So that's locations 2 is ace. And then you end at location 6. So that's why ACSL, remember there's a space here. So 1, 2, 3, 4, 5. And location 6 is over here. It's a D. Okay. And then H0 means at this index 0 position, what's the letter? That's a letter A. Okay. So that's how it works. Let me see if I can close this. Okay, this is one of the simple program which we're running. I will try to show you in the sample here. Okay, let me see if I can clean up. Oh, I forgot how to clean up that. This one. Okay, clean up all, join. Okay, cool. Okay, so I have some quick example in Python language, just in case you know Python, that would be great. So the first one is that demonstrate how to use the condition. So if else. So I have the first number P as 5. If P is smaller than 10, you will print out this. Okay, so I wipe out this all done, and then only run this. So I show you. So they will say, okay, P is smaller than 10. And then you can see the P is 5 here. Okay, that's a conditional statement. And then I can show you how the while statement works. Okay. So you can see, I start as 1, and if I is smaller than 6, they will repeat. But every time after the repeat, they will increment. The I will become 1 number larger than that. So I will become 1, 2, 3, 4, 5. But you just remember that if I equal to 3, they will break. So that means they will jump out. They will not really continue that anymore. Of course, this is a little bit advanced, so don't worry too much about that. So what you need to understand is that you will go through this condition only when this condition is true. So that means only when this condition applied, you will go to over here. So that means 1, you will print out the 1, and then 1 is not to 3. So 1 will plus 1, so become 2. And then you can print 1 out. And then 2 will print out the 2, and then 2 is not 3, so they will become 3, and they will print out the 2 again. And then there will be 3. 3 is equal to 3, so they will break, they will going out. So that's how this works. Okay, so I wipe out this. Second example, I go to, oh, I forgot a for loop, but anyway, for loops here. Okay, so I will show you how the for loop works. So this for loop, I have the X is 2, 4, 6, 8, 10, 12, 14, 16, 18. And then the range means you have from the first position, first index to the last index. So you can print out this per index. So that means always remember the first one is 0, right? So you have print out that, and then you can get the number out. 2, 4, 5, 6. Oh, yeah, that's because I don't really. Oh, why the print out this? That's very interesting. I don't even count that. Range. Oh, I'm sorry. Yeah, because this is inside the range from 2 to 6. Okay, so you only have 2, 4, 6 here. 2, 3, 4, 5, 6. And this is repeat. This is repeat how many times? Okay, so that's why you have 2, 3, 4, 5. That's why. Okay, so this is range. and don't worry too much about this. Okay. And then I can show you this about string. Okay, about string is also very important. So now we have the first string is like this, testing string, right? Okay, when I run this, you can see the testing string is like this, but you get the first index, that's T. And then you get from the first one, so that means 0, and first 3 letter, so that's TES. And then this is from the back end, so that's from the last one. So the last one is G, right? So you have the last one here. And then you move to this position, that's 4. Okay, 0, 1, 2, 3, 4. So that's T. Oh, that's I, I'm sorry. 0, 1, 2, 3, 4. Yes. Okay. And then you can have the 4 to 10. So that's really how the 4 to 10 represent here. So from 4, 5, 6, 7, 8, 9, 10. The 10 is not count, it's up to 10. So that's how this will be. Then you have another string, it's end. Just remember, I intentionally put a space here. So if you put both of these string concat, they become another string. So this another string is like this, testing string end. Just give you a quick example. If I remove this, you can see what happened. That means the testing string end, they have no space in between. Just pay attention to the space. Okay, so I remove all of this and quickly show you one of the more complex example. Okay, I just simplified this a little bit, so you don't have to worry too much about that. The first part is define the how many rows and how many columns for an array. You don't have to really worry about the syntax because this is the Python. In case you don't really know this part, you can learn this quickly. It's not that hard, so just need some practice. And then you have the initial value, A00 equals to 1. So that means if you remember that you have the array, this two-dimensional array, the first index, first row, first column, its value is 1. And you can initial the sum to store the summary of all of this. Okay, then you can loop through. Since you have two-dimensional, so you have two loop. So you have one loop is at the rows, another loop is at column, and then it can run this. Okay. I'm sorry, this is a little bit lengthy. The whole algorithm, what we are implement here is that when the I smaller than j, they will times 3. If it's not smaller than j, they will -2. I will not really go through all of this one by one, but just in case you want to try it, give it a try. And this is really helpful to help you to understand the whole logic. So the logic is from the I from 0 first, and then j is from 0 first. But when the I is 0, they will go through the j from 0, 1 to 3. They will go through all of these 3 rows first. So that means this part will be running first. And just remember that every time the eighth will plus its own value. So that means they get the total of the whole array. That's how they get the result. Then the end result is 8. So that means the sum is 8. And it shows you how the array was really calculated like this. Okay, so I don't really think we have time to give you too much details, but we should have presented enough detail for you to understand how it works. If you have any question, please let us know. And in the Google Classroom, I will post the second topic, the articles and practice. Every week we will have assignment. Please try to finish the assignment. I know some of you may feel struggle to finish that. Spend at least 1 hour or 2 hours to study the learning material, and then try to complete 1 or 2 of the question, and then you will build up your confidence and say, oh, I know how to do it. Or sometimes if you feel struggle, just post the question in the Google Classroom. So no question is stupid question. The only thing what we are not really say is that if you think you understand that, but in the end, when you see the question from the ACSL, you really get confused. That's something we do not want to see. I want you find the question, practice, and then go back to find the question again and practice. I believe you can all get the full score. And this year, you can find your potential and say, oh, I really can understand something more advanced. And it's really, I feel so enjoyable. Hopefully that's what we can say. Thank you so much. And you have a great weekend, and probably
Bye, Mr. Pan. Have a good weekend.
yeah, thank you. Thank you. Bye.